Hi everyone, we're going to use Cramer's rule to solve 2 by 2 and 3 by 3 systems of linear equations. So basically I have an example here that goes with this. And basically what you do is you take the determinant of A, and then for X, and we're going to put in our Y. So right here I'm going to put in B, D, but since we're solving for X, I'm going to put in E, F here. I'm going to do an example in just a minute so you can see. For y, I'm going to go ahead and plug in my x values, which is a, c, the coefficients. But since I'm solving for y, I'm going to put in e, y in the y spot. So let's do an example here. So first of all, I'm going to find out the determinant of a. So the determinant of a would be here. We're going to put 9, 4, 3, negative 5. And find the determinant of that, which equals negative 45 minus 12, which equals negative 57. Now I have to find x. So x is going to equal, since I have my, let me do a different color, I'm going to put, for my x, I'm going to put in my y values, which is 4, negative 5. But since I'm solving for x, I'm going to put in these two values, which is negative 6, negative 21. All over my determinant of a, which is what? Negative 57. Okay, and then for my y, I'm going to fill in my x values, which is 9 and 3, but I'm going to put negative 6 and negative 21 in, all over my determinant of a, which was negative 57. So now I take the determinant, and for x, I'm going to get negative, I already wrote this down so I wouldn't make a mistake. So I'm going to get 30 plus 4 times, it's minus, let me just go ahead and put minus a negative 84 over negative 57. And for my y, I'm going to get negative 189 minus a negative 18, all over negative 57. And when you fix this up, you should get x equals negative 2, and y equals 3. And what you can do, so our solution is negative 2, 3. And you can plug those in to the original equations here and they will work. Okay, so for the 3 by 3, we have this kind of different scenario. So for x, what I want to do is, for x, I'm going to put in my y, which is b, e, and h, and then my z part, which is c, f, and I. But for my x component, I'm going to put in j, k, and l. All over the determinant of a. Okay? And I think I'll move my y up here. My y is going to be this. I'm going to put in my a, t, and g, and my z, which is c, f, and I. But for my y component, because I'm solving for y, I'm going to be putting in j, this column here, j, k, and l, divided by the determinant of a. And then for z, it's the same thing. You put in your x and y components, which is a, t, and g, then b, e, and h. However, for the z component, we're going to put in j, K, and L. And then you already know how to take determinants on this. So I have an example, and I'm going to find X first. So X is going to, well, first of all, I'm going to find the determinant of this. So my matrix is -1, 1, 1, 4, -1, 4, 1, 2, -1. Okay, so to evaluate this, I'm going to take, let's see if I can squeeze it in here, -1 times the determinant of that, which is -1, 4, 2, -1, minus my 1 times my determinant of these pieces, which will be 4, 4, 1, -1, then plus 1 times that part, which would be 4, -1, 1, and 2. So when I take my determinant, I'm going to get -1 times 1 minus 6. So 1 minus 6 is -5. Minus 1 times -4 minus 4, which is -8. Plus 1 times 8 minus a -1, so that's going to be 9. So I get 5 plus 8 plus 9, which gives me, whoops, sorry about that, 14 plus 8 is going to give me 22. So my determinant of A equals 22. Now we fill in everything else, and I'm going to have to keep looking back and forth here. So let me find the problem. All right, so is this the one? Yeah. All right, so here we go. We know our answer is 22, sorry. So for X, we're going to plug in our X values. Well, not our X, we can plug in our Y's, which is 1, -1, 2, and my Z, which is 1, 4, and -1. But for the X values, I plug in 3, -14, and 9. And this is all going to be over 22. So you take the determinant of that, which is going to be 3 times 1 minus 8, which is -7, minus 1 times 14. I'm doing these two here. 14 minus 36 plus 1 times -28 plus 9. So that's going to give us -21. And this equals 22, -22, so it's plus 22. And this is going to be -28 plus 9 is -19, so that's going to be plus 19. 1 times 19, yeah. Wait, minus 19. Great, I'm getting purple here. So that's going to be minus 19. So this equals 1. So 1 minus 19 is -18. And so we get -18 over 22. And you reduce that, let's reduce it by 2, and that gives us -9 over 11 is our X. Now I'm going to go ahead and set up your Y and your Z, and I'll let you do the computation. You can also do this in the calculator. but I want to just be sure to set it up. So hopefully you have this written down. Y is going to be over 22. You fill in your x and z part, so that's going to be -1, 4, and 1. Your z is going to be 1, 4, and -1. And then for your y part, because you're solving for it, you're plugging in -3, -14, and 9. And then you just take, this is a 4. Then you just take a determinant of that, and z is going to be the same type thing. You're going to plug in your x and y components, which is -1, 4, and 1. Your y is 1, -1, 2. And then for your z part, you're going to plug in -3, -14, and 9. And then you just take the determinant. Oh, this is all over 22. All right? And that is how you do Cramer's rule. Especially when you're doing the determinants of these, basically you're taking the determinant of these. You can also do it in the calculator, which makes it a little easier. Okay, this is all, and I hope you all have a nice day.